All right, so I figured we'd do a couple more, just little sort of standard. These are both a multiplication and division problem, but just kind of make sure you got this stuff down real well. This one I remember always giving people fits, and I don't think it should, but it always seems to do that. So I like to consolidate this to a single fraction right away. So remember, you would just multiply everything across in the numerator, and then everything across in the denominator, and then we'll simplify from there. Because everything's already factored here. It's not like this problem where we need to actually factor some of these quadratics out. These are just straight up monomials, which means multiply them together. So 2 times 3 is 6. X, there's no other x's to multiply by it, so it's just x. Y to the first times y to the fourth becomes y to the fifth. Remember, when you multiply terms, you add their powers. Down here, just 4 times 1 is 4. X squared times x squared, add those to be x to the fourth, and then y squared. And so at this point, we're kind of at the intermediate step. We've got one single fraction. Now we just need to reduce this one down. So 6/4 we know reduces to 3/2, just like a normal fraction reducing. X to the first and x to the fourth. So this 1x up here is going to eliminate one of these down here, basically knocking it down to a 3. So we're going to have x to the third in the denominator. Y squared, 2 of these are going to get rid of 2 of those, so knocking that down to a 3. So we're going to have y to the third up here. And so that's going to be our answer. As always, include the restrictions. Since both x and y are in the denominator, then neither x nor y can be 0. And there we go. All right, so for our next one here, this is a division problem. Pay close attention to your signs. Division means we want to rewrite it as a multiplication problem. So I'm going to set it up as just one big fraction. And as I do it, I'm going to go ahead and get everything factored. But what we're going to do is we're going to invert this to change this to a multiplication problem. So I'm going to factor it as I go. X squared minus 9 is a difference of squares. So x plus 3, x minus 3. This part's going to be in the numerator now. So we'll go ahead and we'll factor that. All right, so this one here is going to factor 2. Let's see, we probably use 5 and 3. Yep, those would add to 8. Perfect. So x plus 5, x plus 3. All right, then we move to this denominator. Another difference of squares, so x plus 5, x minus 5. And this just jumps to the denominator. It's already in factored form, so looking good. Okay, so this is kind of our intermediate step. We got one single fraction. Let's look at what we can eliminate here. So an x plus 5 with an x plus 5, x plus 3 with an x plus 3, and I think that's about it. So these two parts are going to be in the numerator, x plus 3, x minus 3, and the x minus 5 in the denominator. So that looks like our simplified answer. Lastly, as always, let's state the restrictions. So the key here, anything that's ever been in the denominator, which is this, this, and then when they flip, also this. So any of those things. So basically they're here, 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 here. Look at all those. So that would be negative 5, positive 5, negative 5 again, negative 5 again, negative 3. So 3 restricted values in this case. And that's it. So make sure you've checked out the review, and then good luck with the quiz today.